Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by SatSearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organizations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello and welcome to today's episode. Today I'm joined by Thijs Cronje, Chief Commercial Officer of SimeraSense. SimeraSense is an Earth observation company based in South Africa and is a member of the SatSearch membership program. The company manufactures optical payloads for clients around the world and supports mission teams with design, integration and operation. Today we're going to discuss some of the factors that are driving commercial demand for Earth observation payloads. But firstly, Thijs, I'd like to welcome you to the Space Industry Podcast and ask if you'd like to add anything to that introduction.
Thank you very much, and thanks for the opportunity to join you here today. I think you've nailed it with your introduction, and there's not much more that I can add.
Fantastic. Okay, well, let's dive into today's topic. Earth observation is obviously a huge part of the industry, the new space sector that as we know it today. I wondered if you could just provide a quick overview of some of the key drivers that are leading to Earth observation satellites, really taking off in the last few years.
Yes, we are definitely seeing an explosion in the demand for Earth observation instruments, especially over the last couple of years. There can be various reasons or drivers for that, but let us try to isolate a few. So over the last decade, the industry got quite a bit of attention, and if I say industry, I mean the new space industry, got a little bit of attention from commercial players across the value chain. We can just think about SpaceX and Blue Origin and all those big companies getting a lot of attention. Now, they are really putting us on the spotlight. And then you've got companies like Planet and Satellogic that are showing the industry that commercial Earth observation is possible with smaller satellites. So that's playing a big role in the perception of the industry. Due to this growth, we are seeing more investors joining the party as well. The access to capital is fueling this growth. Due to all of these developments, it's becoming much easier to get into space for smaller companies. To be honest, getting into space is not a challenge anymore. And then the demand for Earth observation data is growing as well. Today, we are seeing even insurance companies using Earth observation data to deliver product to small farmers across Africa and even in India. It is no longer only governments procuring Earth observation data, but also startups. And then free data from space agencies are also gave the industry quite a boost. Think about just the impact of the whole Copernicus program. It's changing our whole perspective on this industry. Add to this the advancements we've seen in technology like advanced processing. Yes, and then we are in a perfect storm.
Great, interesting. So lots of factors at play, really, both on the public and private side. And I think we hear a lot of talk about constellations, small satellite constellations. They capture the public imagination quite easily, and obviously there are multiple topics that are discussed about them in terms of traffic management and all sorts. But there are lots out there that are planning daily revisits to certain parts of the world. When we think about those technical challenges that they face in terms of the actual Earth observation payloads that they have, what sort of bands and resolutions do you think are under-addressed in the existing constellations or those that are planned, but would have really deep value for end users?
That's a good question, and I think you've made a good observation there. At SimeraSense, we are seeing a huge demand for especially hyperspectral instruments and instruments that can provide spatial resolutions of below 1 meter GSD. On a daily basis, we are getting requests for those kind of instruments. However, there's not I don't say a silver bullet answer to your question. I believe the correct question that the new players in the Earth observation industry must ask is, what challenge or problem are we trying to solve for our customers? The problem you are trying to solve then will determine your spectral, spatial, and radiometric resolution that's required. We all understand that Earth observation instruments are actually a measuring tool. It measures something. You are usually measuring some form of activity on the Earth from space, and you need an answer from that. Now, the question is, how accurate does that answer need to be? 95% accuracy, 85%, or 50%? It's all determined by your application. Now, this will feed back into your choice of spectral, radiometric, and spatial resolution. Let's say, for instance, it's an old example of people that wants to try to count cars in a parking lot to determine economic activity. Now, how accurate do you want that number of cars? If must it be 99.999% accurate, or is 80% accuracy good enough? So yes, that's a big driver in your choices for spectral, spatial, and radiometric resolution. But that said, from a smaller satellite perspective, the longer wavelengths are pretty much still under addressed. So, but we are seeing a lot of action in that sector as well. So I would recommend anybody that wants to fill a gap in the small, let's say, CubeSat kind of Earth observation industry, look a little bit at the longer wavelengths and forget about spatial resolution.
Right, interesting. Yeah, very much application driven, problem solving considerations there. So, just to turn briefly to things from a supplier's point of view. Now, there are lots of different approaches in the industry to setting up a commercial service or a business case or a business itself for based on Earth observation technologies. Now, we've seen operators that are vertically integrated to produce their own payload, such as Planet, who you mentioned earlier, whereas others are sourcing cameras from suppliers like yourselves and integrating that into the systems that they're developing. What is your take on these two approaches? Obviously, you have a lot of interest in the one area, but just wonder what you thought about these two approaches in the industry.
Yes, we think pretty much a lot about it, but it's a good question. And I think as engineers, we love the challenge of building vertical integrated companies that's focusing on a product. But as I said earlier, we want to rather focus on the specific needs or problems that you want to solve. So while the real challenge is more related to your business model innovation, I think one should focus a lot more on that. But then again, it's also about how much control you want to exercise over your whole value chain. So for companies like Planet, it's good for them to do this vertical integration because then they've got the whole value chain under their control. But for us, first of all, I believe you need to focus on your strengths. Focus on what you are good at and where you can add the most value. And for the rest, you can form a nice, innovative partnership with a supplier like us, and then let them do the heavy lifting where you are weak. So, secondly, there's a lot of risk in developing optical payloads. It's difficult. Take it from me. It's not that easy. You need to know, you need the know-how and the infrastructure. It's not, and the infrastructure it takes time and money to develop and scale. If you're a company like Planet Labs, to go from one optical payload to 150 optical payloads, it's a total different ballgame. So there's a lot of investment that needs to go into that. Lastly, I think investors themselves, for them, time to market is everything. So if you first need to develop the infrastructure to develop your payload, then you've got a long and bumpy road ahead of you. So that's my belief on your question.
Right, interesting. Yeah, I think the fact that it is possible to create these partnerships and develop your own supply chain, from what we've seen and the teams that we've worked with, this is more achievable today than it was even 10 years ago, which is a good thing for the whole industry.
Definitely.
Yeah. Okay. So, and then looking at the performance of Earth observation payloads themselves, people usually want to squeeze as much performance as possible within the physical limitations of the satellite bus. and the smaller the satellite, the more crucial these decisions and compromises become. I wondered if you could give a bit of an overview of the scope of Earth observation payloads in small satellites. What sort of resolutions can be achieved in a CubeSat form factor, for example, and what decisions need to be made from an engineering point of view.
Yes, I think you're 100% correct there. It's the story of my life. Every day I need to explain to customers that 1 meter GSD is not possible with a 12U CubeSat, even less with a 6U CubeSat. And there's a perception that it must be possible. Huh? Just make this pixel smaller. But no, it doesn't work like that. Not at all. And the physics are quite simple. Huh? You can't place dice with the physics. And so, for instance, for a 100 millimeter aperture system, you are limited to about 4 meter GRD. Now, GRD is ground resolved distance. So that's what your optical system allows you to see. In the visible and near infrared range from 500 kilometers, it's about 4 meters. So yeah, it won't help go smaller than that. And as soon as the wavelength goes longer, then that limits also is higher. So for instance, for a 200 millimeter aperture, which you can use easily in a 12U or 16U kind of CubeSat, the limit is just above 1.5 meter from 500 kilometers. So yes, there's lots of physical limits, and then there's some other things that you also need to address and can influence your GSD, and that's the stability of the satellite. You need a very good ADCS to make sure that you can achieve that high resolution. And then the thermal stability of your instrument must also be very stable, because any thermal variations in your instrument can influence the GSD as well. But that said, GRD and GSD is not the alpha and omega. One must also ask how much contrast or modulation do you want to transfer from the image to the object. We are a little bit spoiled with large satellites that's got an end-to-end MTF of about 25 to 30%. But you must ask yourself, will 5% also do the job? And again, you need to look at your specific application and especially your budget. And for a given application, there's always an optimal cost efficiency versus instrument accuracy point. And it is the entrepreneur's job to find that specific point where he wants to operate for his specific application. And that is where companies like us can play a role to assist customers making those kind of choices regarding GSD, MTF, spectral resolution, and radiometric resolution. Of course, it's quite a few balls you need to keep in the air.
Yeah, absolutely. And back to that application. I mean, do you need, if you need 80% accuracy counting the cars in the car park, do you need 1 meter GSD and 25% MTF? Possibly not. So yeah, interesting. So another area of the technology that in general in small satellites that people have been talking about quite a lot and we've been discussing with some suppliers is deployable systems. And obviously Earth observation payloads have, as you've discussed, have a lot of complexity, and there's a lot of sensitivity involved in terms of the thermal and mechanical stability, as you've discussed. But do you see that there being scope for deployable Earth observation payloads in coming years in order to engineer better resolution of imagery within the same size satellite?
Yes, I think your assessment is quite right. It's quite correct. We see a lot of activities in that domain already, but only on a research level, not commercial yet. So yes, I think in the next 5 to 10 years, deployable systems will become a reality as the technology evolves and matures. So it's really something that we will evolve towards. And it's nice, but it won't come without its risks and challenges. And you've mentioned a few there: the thermal stability, just the accuracy. We polish our mirrors to 10th of a wavelength, and that's the kind of accuracy you need and align your systems to. So when doing that in space, deployable, it's not easy. But yeah, the short answer is yes. I think within, especially definitely within the next 10 years, we will see frequently deployable systems in space.
Interesting. And to go back, we mentioned briefly about the different bands and the services and the applications that can fall within them. Now, beyond RGB, multispectral SAR, there's also a bit of interest emerging in hyperspectral SWIR bands. Do you believe that the time is coming for these bands to garner more major commercial interest, and for even for constellations to be established in such bands as well?
Yes, definitely. I definitely believe so. The longer wavelengths are still little bit untapped, and it can unlock a wealth of information about our planet. Just think about the resource management, mining, and pollution monitoring. There's much more information for those sectors in the longer wavelengths than only in the visible wavelengths. But so by sampling the longer wavelengths in more detail, we will be able to monitor a lot of challenges here on Earth much more accurate. We are already seeing a few commercial players and entering the shortwave infrared, as you mentioned, and then the thermal infrared spectrum with quite nice and innovative business models. There's quite a few of them on that's starting to develop. And so I believe within the next 5 years, observation within these bands will become standard and will give us a whole new perspective of our planet. And with this, new applications will also develop.
And then to consider the data that would be connected from such new innovative business models and constellations, and obviously all the existing satellites and constellations that we have today. Do you see? You mentioned earlier that what part of what's driving a big boom in interest in Earth observation systems is the availability of free data from space agencies. Do you see moving forward there being sort of a standard industry setup where commercial operators are mainly driving the Earth observation segment using some of the free data from space agencies? And in this industry, do you think that there are lots of sovereign countries that would increasingly prefer using such commercial imagery rather than acquiring it themselves through their national space agencies?
Yes, I think you summarized again beautifully there that free data from space gave the commercial players a major boost over the last 10 to 15 years. And I mean the application developers. So suddenly the application developers have really good data, really very good data to work with for free. And with which they develop a lot of new applications and use that data as a real nice test bench for future applications and for higher resolution data. I'm of the opinion that free data from space agencies have moved the whole Earth observation industry from a technology push to a demand cycle, and especially from an application side, and that's quite nice. On the back of this, commercial Earth observation operators and new players were able to identify gaps within the market and position themselves to address these needs and gaps. Now, Earth observation data is becoming actually a commodity today. A few years ago, it was still a luxury or niche, but now we see it's becoming a necessity. So therefore, data prices will come under pressure, and the focus will shift to value-added services away from only providing data. And yes, government or public organizations can develop and operate Earth observation constellations as cost effectively as the commercial sector. And this will drive the shift towards using commercial imagery. Just think of Planet Labs, how effectively they are managing that constellation and distributing the data. No, I don't see governmental organizations operating in that way. The same with SpaceX. The cost that they can launch rockets into space, the governmental sectors or agencies can't do that. So
Yeah, it's exactly the same situation. Yeah.
yes. So in short, as Earth observation data is becoming a commodity, and governments will source data from commercial players more frequently. It's just what will happen.
Yeah, and like you say, the ability for application developers to focus more on value-added services and the innovation that can result in could be good for everybody. So that's great to see. Now, I think just as a final question, we've touched on quite a few actually of your different predictions, different areas for the Earth observation industry. I wonder if there's anything else that you thought is likely to happen in the next 3 to 5 years, or anything that you are particularly excited about at Samira Sense, or that you see as opportunities for the industry in general. I wondered if you could just put your predicting hat on and share the future with us.
Yeah, it's always nice to try to look into a glass bowl. That's a frequent topic in our company as well, to try to look into a glass bowl and predict what's going on. But I think what the trends that we do see today is that Earth observation instruments are generating a lot of data, way more much than we can use. I've heard numbers that only 5 to 10% of the data downloaded are actually being used. So the rest are just lost. It's not either not usable or there's just no interest in it. So I think the focus of the next 3 to 5 years will be on how can we handle all this data in a more cost-effective manner and optimize the data paths and that. And get all rid of the inefficiencies in the system. So it will be all about addressing and streamlining the bottlenecks within the value chain. Therefore, a lot of focus will be on onboard processing to get the information and ultimately the insight that you need as fast as possible in the hands of the correct decision maker. And we will try to short circuit those loops. And with this, we will also see a lot of Earth observation products being integrated into various decision-making processes, especially in the retail, financing, and insurance industries. So Earth observation will play a major role in how the agricultural or the green, and especially the blue economies are being financed and insured. So we'll see a lot of applications and in places and the use of Earth observation where we traditionally haven't been used in the past. So in short, the way the men in the street are consuming the Earth observation data will change dramatically over the next 5 years. A lot of application developers are currently focusing on just that. And that will have a direct impact on how instrument manufacturers are approaching optical payloads. So yes, in short, the next 3 to 5 years are going to be extremely excited for the whole Earth observation industry. And yes, we as a company can't just wait for that. And yes, we will always try to drive that process and see and work across the value chain with partners to make all of these things happen.
Oh, well, fantastic. I think that's a great place to wrap up. I think, you will have taught our listeners a lot today about all the different aspects of the Earth observation industry and how all these criteria play into each other and affect each other. So, thank you very much for sharing these insights with the Space Industry Podcast community today.
Yes, I must thank you, and thanks for this platform and the opportunity. I think it's great to have these kind of discussions. Thanks a lot.
Great. Oh, you're welcome. And thanks to all our listeners out there. Remember, you can find out more details about Samira Sense's portfolio and services and history of the company on our platform at satsearch.com. You can also make free requests for further technical information, documents, quotes, lead times, and introductions to companies, or whatever other information you might need for your trade studies or procurement purposes. Thank you very much. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.